What do you do today can improve all your tomorrows. Dear professors, I welcome you all for the AICTE-ISTE sponsored 6 days refresher course on Anaconda Data Science Techniques. The agenda for the day contains 3 sessions. First session will be on predictive model linear regression, and the second session will be on classification techniques using decision tree and random forest. And the last session of the day will be on clustering algorithms. Without further ado, let's get started. Session 10 will be on predictive model linear regression. It will be handled by Mr. Sudarshan. Without further ado, let's get into the session. Over to you, sir.
Thank you, ma'am. Good morning, folks. I hope all of you are doing good today. And the topic which we have got for today is predictive learning. What it is all about means we need to study already existing data set, how does the data behaves and those things and all. And this is not going to be a theoretical class, unlike yesterday. This will be a full-fledged practical class, where we'll be analyzing a kind of algorithm which is being used in data science. And this is the most primary and basic algorithm which we need to learn if you are enthralling into data science stream. Okay, so we all know what is data set, what is prediction, and what are the process of prediction. Data set is already existing data which helps us to identify the data behavior and those things. Prediction means we need to identify the pattern in which the data has performed, in which the data has got created, something like that. Then based on that we need to create a pattern, how it will behave in the future, something like that. And it has its own set of process, how we need to analyze the data, identify the factors, interpreting the pattern which is already existing, and how it will behave in the future, something like that. Then okay, here let us take a case. For example, this is the case which we are going to analyze today. The vehicle that is traveling in a national highway from a location A to B. You have split the entire distance into 5 equal parts. Ideally, the vehicle is being assumed to travel in the same speed, but in the real-time condition, it will not travel in the same speed. If it tries to travel in the same speed, it will cover the same, 5 equal parts at the same time. It should be right, but in a real-time case, it will not, due to many factors. The road might not be good, or the speed of the vehicle might get slow, due to speed breakers or harms, something like that. We need to understand what could be the reason for the variation in the total time taken in covering the same equal amount of distance. Okay, so for that we need to take two cases. Say for example, this is a linear set, and this is non-linear set. Before entering into this, I just need to make sure, if any of you having any doubt at any point of time, please ask at that time itself, because it is very important and basic algorithm which we must learn. Okay, so fine. This is the speed. Speed is constant, 60 km per hour speed. At the end of 5 minutes or 5 something like that, 5 units of time, the total distance covered is 10. Twice the time the distance is being covered here. 10 into 2, 20. 15 into 2, 30. 20 into 2, 40. 25 into 2, 50. So here it is equal distance at equal time. But in the non-linear case, at 1 unit is 3 units of distance being covered. At 2 units of time, 4 units of distance.
Are you sharing your screen? Sorry, sir, I'm not able to see your screen. Your screen is not visible to me, actually.
Okay. Is it visible now?
It is visible now.
Is the screen visible now?
No, no,
Yes,
not
sir, it is
visible.
visible.
Okay.
Yeah, it's visible now.
Okay, fine. And sorry, Aikit, you could have asked me before itself, right? I didn't see that I have. Okay, fine. This is the case which you're going to deal with now. I hope everyone got understood, what is the exact scenario which you're going to follow now, right?
So you can start from the beginning. Actually, it is not
Yeah.
visible, no? So
Okay. This is the beginning. Like, I mean, everything else is fine. Like here, we are going to go ahead with the linear regression. Linear regression is the basic algorithm which we'll be following in data science. So we need to understand like what it is and where it can be used. So this is the scenario with which we'll be figuring out like how we can go ahead with linear regression. Here a vehicle is going to travel in the national highway like from location A to B, and that entire distance being split into 5 equal parts. Ideally the vehicle is assumed to travel in the same speed, but in actual real time it will not. The speed or the distance covered in the same time might be different due to many factors. We need to identify why those variations are happening using this linear regression algorithm. Is it clear for everyone?
yes, yes, yes.
Okay.
Yes.
Okay, so for that we have got a sample database, I mean data set. So here speed is assumed to be same. Here also speed is assumed to be same. In linear case, total time taken is 5, 10, 15, 20, 25. Distance covered is into 2, like a 5 into 2, 10 into 2, 15 into 2, 20 into 2, 25 into 2. So if you plot these points in the graph by taking time as x-axis and distance as y-axis, it will be linear, like it will be in this form. Okay. Now,
Yes.
if you take non-linear means, if you consider here time 1, 2, 3, 4, 5, but here the distance covered is varying. We need to understand like why the distance is being different and what pattern it is being following. We need to figure out that. That is the task of this linear regression. Okay, so these are the 3 formulas which we need to use in linear regression. Like line equation formula, like most of us would have come across this formula, like y is equal to mxc since our school days, because this is the formula that is being used for drawing a line in a graph sheet. Like y is equal to mx plus c. This is the basic line equation formula. This is used to plot the points in the graph and draw a line across that. So we need to identify this m value, we'll be using this formula. M is equal to summation of x minus x mean into y minus y mean, the whole divided by summation of x minus x mean, the whole square. And R coefficient formula, like I'll tell you like why, what is the reason for this. Why do we need this R coefficient? R coefficient is to check like how linear the data set is actually. This one you can ignore as of now. I'll tell you in the later part. First, we need to identify these 2 things. Okay, so let us create a data. Let us work on the data sets now. Okay, like first, let us go with the linear data set. In linear data set, we need to find out those values. X, Y, 1, 2, 3, 4, 5, 6, 5, 10, 15, 20, 25, 10, 20, 30, 40, 50. First, we need to calculate the mean value. Mean value is nothing but average value, x underscore mean. It is 5 plus 10 plus 15 plus 20 plus 25. The whole should be divided by total number of elements, like divided by 5. It is nothing but 15. Similarly, the mean value for y mean is equal to y underscore mean equal to 10 plus 20 plus 30 plus 40 plus 50 whole divided by 5 equal to nothing but 30. Got it right? This part? Okay. So First we have calculated the mean. Now we need to calculate the m coefficient value and c value. This is the formula which we need to use for m coefficient. M is equal to summation of x minus x bar into y minus y bar. So we will calculate those details now. Insert x, y, x minus x mean, y minus y mean, x minus x mean into y minus y mean, x minus x mean, x, y, x minus x underscore mean, y minus y underscore mean, x minus x underscore mean into y minus y underscore mean. Then followed by x minus x underscore mean whole square. Okay, so we doesn't require this column, entire column. I don't want. Okay, so x values are 5, 10, sorry, 15, 20, 25, 10, 20, 30, 40, 50. X minus x mean is like a here it will be minus 10, minus 5. Here it will be 0, it will be 5, it will be 10. I hope you're following right. At any
Yes,
point
sir.
if you have, okay, at any point you have doubt, you can ask me, like, because if you miss at any point, you will not be able to follow with this. So now we need to calculate x minus y. So here it will be 200, like minus 10 into minus 20, it will be plus 200. Minus 5 into minus 10 will be 50. It will be 0. Here again it will be 50. Here it will be 200. X minus x mean, if you make it as a square, then it will be 100. 5 into 5, 25, followed by 0, again 25, again 100. So now we have found out like the m, I mean, you can find the m value. M value is equal to summation of these values, like summation of this value, like 100, I mean 200 plus 200 is equal to 400, 400 plus 100 is equal 500. Okay, so here it will be like a 250. So m value will be 500 divided by 250 is equal to 2. Now we need to find out c value. C is equal to y equal to mx plus c. So we need to bring mx to that side. So c will be equal to y minus mx. Equal to y value is mean value here. We need to take this value as y value. Y should be 30 minus m is 2 into x value is 15. It is equivalent to 0. So c value is 0. Okay. So now we have found out m value, c value, x mean and y mean. Now we need to find out whether, we need to find r value. Like before that, we need to find another set of data, like a y prediction, like a predicted y. I'll tell you like why we need that. that is actually something like a comparing factor, because we have got actual data. I mean, this is like a assumption. Data set which we have, we need to compare this with another set of data, like that will be used as a benchmark data set. We need to create that own benchmark data set with these values, like a c is equal to 0 and m is equal to 2, y. For that, y is equal to mx plus c. Then for that, y equal to m values 2 into here we are creating another set of data, like therefore x y. This is also kind of data plotting. 5, 10, 20. I mean, here it will not be the same. It will differ. I mean, we need to check whether it will be different or not. 2 into 5 plus c is equal to 0. If it is 2 into 5, it will be 10. 2 into 10 means it will be 20. Similarly, it will be 30 here, 40 here, 50 here. And please note that only for perfectly linear equation or linear plots, I mean a linear data set, it will be the same as this data set. If it is not a linear data set, then this value will be different, this y value. Based on that, we can come to a conclusion like whether the data set is linear or not. And another step of verification is like finding the R value. Finding the R value formula is this one. Here we need to substitute the y prediction value. Y prediction value is nothing but this value, like a 10, 20, 30, 40, 50. Okay, so now we'll find R square. From that we need to take square root. R square equal to summation of yp minus summation of, summation of yp minus y mean the whole square divided by summation of y minus y mean whole square. Okay, so for that we need to create a y minus y pred, sorry, y prediction, y mean, okay, y underscore pred, y underscore mean, y underscore pred minus y underscore mean. This is the numerator part. Y minus y underscore mean. This is the denominator part. And we need another column to make it as a square. Column to the right. Y minus y mean. Okay, so we'll be calculating these values now. Y values are 10, 20, 30, 40. Need another row, which is 450. Okay. Y predicted values are also the same here because it is a perfectly linear condition. 10, 20, 30, 40. 50. Okay. Now we need to find the mean value, which we have already found is 30, this value. So it will remain the same for all the columns. Y minus y predicted value. y value minus y predicted value. 10 minus 10 is, 10 minus 30 is minus 20. Here it will be like minus 10. Better, I'll put all the values.
Excuse me, sir. How did you take the y predicted value?
Here, ma'am, we have calculated through this formula, like y is equal to mxc.
Okay, okay, sir.
Now we are going to find y minus y mean. Again, it will be like a minus 20, minus 10, followed by 0, followed by 10, followed by 20. Okay. So we are going to square up both the columns here. So it will be like a 400, followed by 100, followed by 0, followed by 100, followed by 400. Here also it will be the same, like a 400, followed by 100, followed by 0, followed by 100, and followed by 400. So we have to find out the sum. 1000, 1000. So like r square value equal to, this is the numerator part, y minus predicted underscore mean. And this is the denominator part, like you can see from this formula. Like y predicted minus y mean. Y predicted minus y mean whole square, which is equal to the first, summation, which is equal to 1000. Similarly, y minus y underscore mean. Y minus y underscore mean. Underscore is in the sense like mean. This bar. Summation of this square is equal to also 1000. So it will be 1000 divided by 1000 equal to 1. 1 is nothing but if you take square root of that, r equal to 1. Obviously, square root of 1 is 1. So it is 100% linear. This is our conclusion. In case if the data set is going to be different, say for example, instead of this linear data set, we are going to follow any non-linear data set like this. Then we need to find out how much percentage of linearity the data set has. That is the task which we have. Let us overwrite. Okay, instead of overwriting, let me create a new set itself. Data set 2. 1, 2, 3, 4, 5, 3, 4, 7, 2, 1. Insert x 1, 2, 3, 4, 5, x, y 1, 2, 3, 4, 5, 3, 4, 7, 2, 1, 3, 4, 7, 2, 1. Now we need to find out the mean value. Mean value is nothing but the average value. What could be the mean value here means 3. And here it will be around some 3 plus 4, 7, 7 plus 7, 14, 14 plus 2, 16, 16 plus 1, 17, 17 divided by 5. Approximately it will be like a 3.4. Okay, so like x 3 comma 3.4, this will be the mean plot of this entire data set curve. Okay, so like we have found this value. Now we need to find m value, and for this m value we need to follow the same process like this one. I'll empty the data set now. Delete. X value is 1, 2, 3, 4, 5, 3, 4, 7, 2. Mean value is 3. 3 minus 1 will be minus 2. 3 minus 2 will be minus 1. I hope you can understand right here why I'm directly putting minus 2, minus 1. And hello.
Yes, sir. Yes, sir.
Okay. Here it will be 3 minus 3 as 0. 4 minus 3 will be 1. 5 minus 2, 3 will be 2. And similarly, like 3.4, I mean 3 minus 3.4, it will be like a minus 0.4. 2 minus 3.4 will be like, sorry, 4 minus 3.4. 4 minus 3.4 will be 0 minus 0, sorry, 0.6. Okay. 3.7 minus 3.4 will be equal to 3.6. 2 minus 3.4 will be minus 1.4. 1 minus 3.4 will be minus 2.4. Okay. So we need to multiply these two values, like minus 2 into minus 0.4 will be 0.8. Here it will be 0.6. Here it will be minus, because here only one digit is having minus symbol. So here it will be 0, minus 1.4, minus 4.8. Okay, good. So now we need to find the square value of this thing. It will be 4, 1, 0, 1, 4. So now we need to find the sum value. Like sum value is something like Windows 0.6 plus 0 minus 1.4 minus 2.4 is nothing but minus. It comes around no, sorry, we need to calculate this thing. 0.8 minus 0.6 0 minus 1.4 followed by minus 4.8, which is nothing but minus 6. So our summation of this thing was like a 4 plus 4, 8, 8 plus 1, 9, 9 plus 1, 10. So m will be numerator divided by denominator. This is the numerator part, minus 6 divided by 10, which is equivalent to minus 0.6. So this is the m value. Now we need to find c value. C is equal to mx plus c. Sorry, y is equal to mx plus c. Y is like a mean value 3.4 minus, 3.4 equal to m value is minus 0.6 into x value, or mean value is 3 plus c. Uh, 3.4 equal to minus 1.8 plus c. So we need to bring c towards that side. If you bring it like that, it will be c equal to 3 plus 1, 4, 4 plus 1.2 is equal to 5.2. So c value is equal to 5.2. So we have got both the c as well as the m value. Now we need to follow this process, like predicting y. This is something like a comparison set. That is how we used to call it as. So we need to find out y predictor with the same set of data. Okay, so what are the y values which we are already having? 3, 4, 7, 2, 1. Okay, now we are going to find out y prediction value. Y prediction value is equal to m. M value is nothing but minus 0.6 into X value is nothing but the existing value, like 1, 2, 3, 4, 5. 1 plus C value is nothing but 5.2. It's nothing but 5.2 minus 0.6 is equal to 4.8, I guess. Sorry, 4.6. 4.6. Then it will be followed by, if it is 2, then it will be 1 minus 1.2. Minus 1.2 means 5.2 minus 1.2 is equal to 4, 4.0. Then 7, if it is 3 minus 1.8, minus 1.8 plus 5.2 is equal to 3.4. It is 2.4 minus 2.4 plus 5.2 of 2.8. It is 3 goes like, then it is be 2.2. And the y mean is, we already know, 3.4. Okay, so until this, any of you having any doubt? Hello? Hello? Hello?
No, it is clear. It is clear.
Okay, fine. So now we need to find out the difference between ypred minus y mean. This is the ypred column, and the difference between ypred and y mean. Like a 4.6 minus 3.4 will be like 1.2. 4 minus 3.4 will be 0.6. And a 3.4 minus 3.4 will be 0. 2.8 minus 3.4 will be like minus 0.6. And here it will be like minus 1.2. Similarly, we need to find the difference between y minus y mean. It will be minus 0.4. 4 minus 3.4 means like it will be 0.6. 7 minus 3.4 will be 3.6. 2 minus 3.4 will be like minus 1.4. 1 minus 3.4 will be like minus 2.4. Okay. So now we are going to calculate y underscore pred minus y underscore mean whole square, which means we are going to square this. So 12 12s are 144, 1.44 followed by 0.6, I mean 0.36, like 6 6 are 36, followed by 0. Here it will be 0.36. Again, here it will be like 1.44. Now we are going to make a square of this value. Like it will be 0.16, followed by 0.36, followed by 12. I mean 36 into 36. 3.6. 12.96. 14 sir. 6. 24, 576, I guess. Okay, then it will be 5.76. So now we need to find the sum of these values. (0.16 plus 0.36 plus 12.96 plus 1.96 plus 5.76, 21.2. So now we need to find the sum of these values. 1.44 plus, sorry, 1.44 plus 0.36 plus 1.44 plus 0.36, 3.6. Now we are going to find R square. R square's formula is like this thing. Summation of y predicted value minus y mean, like y predicted value minus y mean whole square divided by summation of y minus y mean whole square, which is nothing but 3.6 whole should be divided by 21.2. Let us find out like what is the actual value for this. 3.6 divided by 21.2, which is nothing but this value is 0.1698. 0.1698. We need to find the square root of this value. Right. Yes. The value for this 41 equal to 0.41 as a holding factor. Yeah, just 0.41, which means this data set is just 41% linear actually. Percentage wise, if you calculate it like 0.41 into 100 will be equal to just 41%. I mean, this data set, the second one which we have taken is just a 41% linear. Earlier was like 100% linear. So we got reason as, value as 1. Like here. No, here R is equal to 0.41. So our ultimate task is like we need to find out how much percentage between 0 to 100 it is being linear. That is the major task. Like we might receive n number of data set. We need to find out whether this data set will suit with linear regression algorithm or not. And right now we have done it mathematically. Now we need to make it as the form of programmatic. Like we need to create a set of codes to execute, to check whether this R value is between 0 and 1. For that, we need to create a program. So mathematically, I hope everyone understood the concept, like how it works. This linear algorithm is all. Right?
Yes, it is clear, but Darshan, you post it in the chat window. It will be helpful for us to.
Like this data set, right?
No, the file whatever you have now made in the Word document, you save it and post it in the chat window. It will be good for us to further reference.
Yeah, sure.
Okay,
Thank you.
You save it and post it in the chat window. It will be that file you can post it.
Sure. Okay. I have saved this. I'll send it to you. Sure. Okay. So let us make it in the form of programmatic. For this, we need the following libraries, like as I said yesterday itself: NumPy, pandas, and to plot the values, we need a matplotlib. Import numpy as np. Import pandas as pd. Import matplotlib.py plot as plt. So now we have imported all the necessary libraries. Now we'll be fetching the data. XLS equal to pd.read read underscore excel. Okay. Followed by the parameters which we need to give are the file name. Since I'm having both the data in the same location, data set followed by excel. Sorry, I'm going to store the data from the particular Excel file in this variable like a data. For that, I need to use pandas pd dot read underscore excel. XLS is the file name. Here we have passing the parameter name like a file name here into this method through this object. I mean XLS, not object, a variable. Followed by sheet name, sheet underscore name equal to like, I think it should be linear. Time equal to data. Then that whichever is whichever column named as time and a header value like for example here this is the linear sheet within this data underscore set. Data underscore set is the file name and the sheet name is linear, this one, and here I'm fetching the time as column. Okay, now I'll be taking the distance value. Distance equal to data ASTANCA. Okay, fine. Now we have stored the distance value here. Now time underscore mean equal to time dot mean. Distance equal to let me save this file. Let me check the value. Print time mean print distance. Here it should be distance underscore mean. Okay, so now we have read the mean value of this data set. Mean value is like 30, sorry, 15 here, and here it will be 30. Since I don't want to disturb this data set, it will be like this. Now we need to find m constant value, m underscore constant score numerator equal to minus time mean into distance minus distance mean dot sum. So this is nothing but x minus x mean, which is nothing but time minus time mean, because time is the value which is we are having considering as x minus x mean into distance, which is nothing but y minus y mean, and total sum of that. This is the just numerator part. Similarly, we need to create a denominator part, m underscore constant underscore d equal to x minus x mean. This is nothing but time minus time underscore mean, and now we need to square of this. It is a square, and this should be summation should be done here. Okay, so now constant equal to m underscore constant numerator divided by m underscore constant denominator. Print m underscore constant. See, like in our earlier condition, we have got that value. M until here we have completed in programming. Now we need to find out a c constant value. C underscore constant equal to c is equal to y minus mx. Y is nothing but distance. Minus y is nothing but distance minus y equal to mx c equal to y minus mx. What is the m value means? Like m underscore constant to okay. It should be distance underscore mean, since we are taking this value, like c value is equal to yes, mean value of y, so which is nothing but distance underscore mean minus 2 is nothing but m underscore constant into time mean value, like 15, and c underscore constant. So now the expected result should be 0 here. This is not required, so it has come here like this. Okay, so this is also executing fine now. Now we need to find out the y predicted values. Which is nothing but distance underscore predicted equal to m underscore constant into time. Here it is nothing but m into x plus c underscore constant. Predicted. So it will give us the value like a 10, 20, 30, 40, 50. Let us check. Yeah, you have found right, a 10, 20, 30, 40, 50. So it is also fine. Now we need to check whether how much percent linear the existing data set is. For that we need to find R square value. What is the process of checking R square value? R underscore numerator, which is equal to YP. YP is nothing but predicted distance predicted minus distance mean. We need to take a square of that. And again we need to do summation operation here. But sum. Similarly, we need to find the denominator value. Y minus YP, which is nothing but distance minus distance mean. Square of that, what sum. R value, I mean, this is not actually R value, it is square of R. So I'll just denote it as R2. R underscore numerator divided by R underscore denominator. Now we need to find R value is equal to R2 to 0.50, which is nothing but square root. Let us check what is the R value is going to be here. Should be 1. R is not defined. Okay, here it is R underscore. Okay, so it is 1.3, which is nothing but 100% it is linear. So I think hope you have got understood like how it behaves for the linear programmatically.
Yes, it is clear.
Okay, so now let us check for non-linear, like how much percentage it is linear with the data.
Participants, kindly mute yourself. There's a disturbance.
I'm just changing the data source here. If it is non-linear, then as we found, like it is 41% linear here.
Mute பண்ணுங்க சார். சார் வா.
இது மாதிரி பேசுறாரா?
இவரு மியூட்ல போட முடியாதா? Everyone வருது.
Okay, so now let us plot this.
அப்ப எல்லாரும் யாருமே பேச முடியாது இல்லையா? அவங்க அன்மியூட் பண்ணி பேசணும்ல. பேசணும் அவங்க அன்மியூட் பண்ணி பேசணும்.
LT dot scatter. Let me scatter the points like time, which is nothing but actually x, comma distance. Now comes plot. It will create a line. Time followed by distance underscore predicted. LT dot show. So this is for a non-linear set. Let me first train you for linear data set. So now, see, like this is the graph which I have obtained for a linear data set. It has plotted the points and the entire linear line goes straight. So if you get this kind of data set, then you can come to a conclusion like the data set is linearly growing. So maybe in the next quarter or the next period of time, in the next year, the company or something like that may expect a same kind of growth. But according to our case, the vehicle will cover the same amount of distance at every particular period of time in a linear condition. But if it is going to be a non-linear, according to our case 2, see here at a unit point of time, about the 3 units of distance have been covered. At the unit point of 2, 4 units of distance have been covered. At the unit point of 3, 7 units of distance have been covered. At the unit point of 4, just 2 units of distance have been covered. At unit point of 5, just 1 unit distance is covered. So what we have found is like whenever the person who is riding the vehicle can go at a better speed when he is covering the third part of the distance, like for example, okay, uh, so like from this inference, distance, total distance covered in first point is like a 3, 4, 7, 2, 1. So whenever the driver drives the vehicle between these 2 points of total distance, like he can drive at a better fast rate, like he can cover more distance during this period of time, because the road might be in a good condition. The vehicle can go without any deceleration, like only good acceleration might be happening. Again, when vehicle is driving between this point to this point, you can find the tremendous slowness. This slowness could be various reasons, like maybe due to heavy traffic jam, or the road conditions might not be good. Road might be not so broader, like it could be very narrow. There could be many reasons. It could be a mountain region, something like that. In that cases, the speed is expected to come down. So like these are the various kind of inferences which you are making out of the data set. So according to our observation, like the second data set is not properly linear. At most, a linearity is like only 40%. Exactly to say like 41%. Only 41% of the data is suiting for this algorithm. So for this data set, we should not apply linear regression algorithm. Like we need to go for some other algorithm like RNN, CNN, or something like that, convolution algorithms. So is there anyone having any doubt?
Participants, if you have any doubt, you can ask our resource person.
Yes, Mr. Sudharsan,
Yes,
I got out here.
Yes.
So in the second data set, we found that the linearity is 41%.
Yes.
So if I want to predict some data based on, this is a non-linear data set, is it okay? But if I want to predict something using linear regression on that data set, whether it is possible or not to find out some prediction.
Yeah, that's what you have found out. Like, okay, let us make it as a question answer session here. Like in the first case, how much percentage it was suiting with the linear regression algorithm?
It is first one is 100%.
Okay.
So without any applying any linear regression also, I can say by applying just only y equal to mx plus c, m is a constant value for everything, and you can tell this is the value.
Yes,
But
that
if
will
my
be fine for perfectly linear algorithm. I mean,
Yes.
perfectly linear data set. If the data set is not linear, like in the second case, then you need to find out the y prediction value. This is actually nothing but a comparison value.
Yes.
So in the according to second one, it is just 41%. So difference will be like around some 59%. It is not matching. We need to find out like what are the factors that are causing this 59% issue. So based on that, you can find out, for example, at some places like between B and C, you can go at a very much faster rate. And between C and D, you are not able to go up to the same speed. The reason is like you can find many reasons, like there could be many traffic jam or something. In that case, maybe government can plan like we can increase another lane, so or we can broaden the road. So those kind of outcomes we can get, like those kind of ideas we can get from the data set.
Sure. But my question is, if my data set is not following the linearity, can I apply the linear regression on that or not? Because in mean square error, we are finding out the mean square error. Then it is for the prediction. We are doing that by making the regression lines, by best fit regression lines. So in
Okay.
the second case, because in data mining approaches, we are doing that. I am not familiar, very good in data science, but in
Okay.
data mining, because data mining is also a part of this area. So
Yes.
what we are doing it whether a data set is non-linear, then also we are applying finding out the mean square error, then finding out the mean square best fitting line we are calculating and predicting some value. Here
Yes.
also, whatever I am finding, it is the same case in the second one. We can find out that approach we can apply, and though it is linearity is 41%, we can predict something. Yes
Yeah,
or
you
no?
can predict.
Yes, yes. That's only I want to know. Thank you.
Okay. Any other doubt from anyone?
Any doubts from participant side? Sir, is the session is going to finish now or you are going to continue?
No, that's all, ma'am. Like it is about explaining the concept.
Okay. Participants, if you have any doubt, you can ask to a resource person. Yes, you can post it in the chat box also.
Meanwhile, I'll share these files with, I don't know with whom I need to share, or is there any option to share in the session itself? Let me check.
Okay, sir.
Excuse me, sir.
Yes, ma'am.
Sir, my question is that while predicting the disease, can I use the data set with non-linear?
Yeah,
Using this linear regression algorithm, how much accuracy will be given for this using non-linear data set?
that non-linear data set accuracy depends on how the data is actually, like in our second case, I think I'm getting echo of my voice. Okay, so in our case, in the second case, we have got 41% linearity. So similarly, your data set might be some 30% or 70%. It depends on. So based on that, you need to list down the factors that are creating that deviation. That is the overall aim of this.
Okay, sir.
So in Python, is there any direct function to find out this coefficient of regression? This R, whatever you have find out, is there? You have coded it very well. It is good to understand. But is there any direct function? Is there?
Direct function, like since we are using summation operation and all, I hope there is no direct function, but we can still reduce the steps. Here itself, I have almost reduced the steps. It is just only 35 lines of coding here, but you can even still reduce it by using some mathematical operations.
Okay. So the environment you are writing the code is PyCharm, I think, na? This is
This is like Anaconda. Visual Code, Visual Studio.
Oh, after going Anaconda, there is a Visual Studio.
Yes,
Like
this
I
one.
am using Spider. I am
Okay,
using
okay.
Spider. So which
This
is
is
one?
VS Code, Visual Studio Code. This one.
Oh, okay. VS Code. Okay, thank you.
Like this is my suggestion. Like can use Anaconda like for everything. Like it is a best one of the best IDE to edit the code. Any other questions from anyone?
Participants, any doubt?
No, ma'am.
You, Mr. Sudharsan, you are working in data science area in industry, I think. No? I have not started with your introduction.
Okay.
So I have joined little bit late.
Okay,
So you
fine,
are in industry in data science area you are working?
No, actually, I'm working in this middleware concept, like integrating data from different data sources and making a collaboration between them.
Okay. Where are you working, sir? Just want to know.
At L&T Infotech.
L&T Infotech.
Yes.
Oh, good.
Okay, many thanks for your brilliant session today, sir. It's a great presentation with a lot of specific and helpful information. Thank you, sir.
Thank you, ma'am.